Hi everyone. In this video, we are going to define postulates, theorems, and conjectures, and use that information to provide some examples. So we are meeting our learning objective G4A, which will allow us to tell the difference between postulates, conjectures, and theorems, and being able to provide examples of each. So we are actually learning 4 terms. We're learning postulates, which can also be called axioms. And these are a statement that is accepted as true without proof. They are the fundamentals of our areas of mathematics that we know to be true. Theorems, on the other hand, are statements that are true, but they have to be proven first. So the big thing in mathematics is that you can't just say something as a fact. Unless it is a postulate, which is a very small category of true statements in math and geometry, theorems have to be proven first. One of the most common examples that you've been using for years is the Pythagorean theorem. Pythagoras, back in ancient Greece, had to prove that his theorem was true before other mathematicians could accept it and use it. Now, once something has been proven, you are able to use it as a fact, and it can be used to prove other things. And then there's lastly our conjectures. And conjectures are a statement that isn't known to be true or false. It's kind of like a hypothesis in science. You're making a guess. You might make a guess based on some observations, but until it is proven true using our rigorous mathematics proofs that you're going to learn throughout the year, until it is proven true, you can't apply that conjecture to make other arguments. Conjectures are often based off of observation or guesses based on patterns. And until they're proven using other postulates and theorems, that is all they are. They are guesses. So now we're going to talk about the difference also between an axiom and a postulate. Axioms are the smallest category of statements we have, and in geometry, there are only 5. In geometry, the 5 axioms are that a straight line may be drawn between any points. Any terminated straight line may be extended indefinitely. By that they mean you can turn a line segment into a line. So in our first statement, if you think about if I were to draw any 2 points, there is only one line, and it is a straight line that can be drawn. Then our third, so we talked about our first and our second axiom. Our third axiom is that a circle may be drawn with any given point as a center and any given radius. That is actually just what a compass is, right? If I tell you that I have a point, let's say A, and a radius of 2, you can make a circle, right? Just by spinning that radius all the way around to make a circle that looks a lot better than that. The next axiom is that all right angles are equal. We know that all right angles are 90 degrees. And if I know that 2 figures have right angles, I know that those angles have to be the same thing. And then, for any given point not on a given line, there is exactly one line through the point that does not meet the given line. By meet, they mean the word intersect. So let's think about what that is. So a given line. So let's draw a line. And for any given point. So they're saying that any point, but it's one point in particular, but it doesn't matter where that point is. So if I draw a line and another point, there is exactly one line through that point that does not intersect the line. Well, how could I draw a line that does not intersect this one? Well, it would look like this. And what did I just draw? I just drew a set of parallel lines. So I just drew a pair of parallel lines. With these 5 facts, we can make the rest of geometry. Now, one thing I want to say about these facts is that this is axioms of Euclidean geometry. Euclid was a famous mathematician, and Euclid defined geometry as we know it, where a line is straight and a plane is flat. There are other types of geometry. A common one is geometry which exists on a sphere. So if you took a plane and wrapped it around a ball and wrapped it around a sphere, that would make spherical geometry. And these facts are not true in spherical geometry. So those are our 5 axioms. Axioms are a very small category of postulates that define a specific type of geometry that we're talking about, Euclidean or spherical or geometry on a torus, any of those things. So now let's see some postulates and theorems and conjectures. So a common theorem that you already know is the Pythagorean theorem. The Pythagorean theorem that a squared plus b squared equals c squared, that was proved by the mathematician Pythagoras and then many mathematicians after as well to be true, and we can use that as mathematicians now. An example of a postulate might be some postulates would be our angle addition postulate or the segment addition postulate. These things are so basic that we have to assume they're true to be able to do a lot of mathematics. And then, so we talked about the Pythagorean theorem, and there are so many other theorems that you might learn, like your vertical angles theorem that we will learn soon, or the angle bisector theorem. Most of the things that you learn and the properties and facts that you learn are probably going to be theorems. And conjectures are any hypothesis. So you might say that I think that, and you can fill in any example of something that you're thinking that you haven't proven yet. It might be that I think that all dogs. Have I done a mathematic proof to say that all dogs have 4 legs? I have not done a proof yet. I might say that I think that all triangles have 180 degrees. Now there are ways to prove that, so once we prove it, we can move it into our theorem section. That's actually called the triangle sum theorem. But until we prove it, it's going to be in our conjecture category, because these things could be true or they could be false. So in the last part of the notes, I ask you to explain the difference between theorems and conjectures, and explain the difference between postulates and theorems, and then try these examples. This time we're going to pause the video so that you can think about these ideas and apply them to these 4 questions. So try these 4 questions on your own. So what is the difference between theorems and conjectures? Theorems have been proven to be true, while conjectures have not. So a conjecture, we don't know if it's true or not yet. Sometimes Conjectures, you come up with an idea and can prove it in 5 minutes. Some conjectures have existed for thousands of years. Hundreds of years. Thousands of years, maybe. They've listed at least for hundreds of years while we try to find out if they're true or not. What is the difference between postulates and theorems? Postulates are assumed to be true, while theorems have been proven true. So once again, theorems have to be proven. Postulates, on the other hand, are actually assumed to be true. They're so basic that we assume them. And if it has not been told to you that it is a postulate, and you cannot assume it's true, those are going to be our conjectures. If they don't tell you it's a postulate, you're going to go with conjecture. So our 2 practice problems. On Monday, Ms. White walked outside and saw it was raining. She said, on Mondays it rains. Is this a postulate, a theorem, or a conjecture? So the question that you ask yourself is, have you proven it? Did I prove it in every case? I have one Monday, and on one Monday it rained. But that doesn't tell me anything about the Mondays in the future or the Mondays in the past. So we didn't prove it. If we haven't proven it yet, then it is a conjecture. So we now know it's a conjecture because we haven't proven it yet. In our second question, which of the following is not an axiom of geometry? The answer is C. We draw a circle with a point and a radius, but you could use those 2 points to create a radius, to find the length of a radius, but the axiom is that a circle can be drawn with any point and any radius. Okay? Thank you for taking the time to watch this video, and have a great day.